We're going to go through the notes for solving trigonometric equations day 2. I basically think that trig equations break into 5 different problem types, and today we're going to start with problem type 3. So we're going to be solving trigonometric equations using the square root property. So I thought it would be helpful to do a quick review of the square root property. So if you have your variable, so in this case, we're going to be solving for x, and a is going to be a number. Okay, so if you have something that looks like x squared equals a squared, to use the square root property, you're going to take the square root of both sides. And whenever you take the square root of a number, you need to remember to put in plus or minus. You need to remember that the positive number can be squared to get x squared, or the negative number can be squared to get x squared. Okay, the big thing that people forget here is that the answer is going to be plus or minus a. Okay, people always give me the positive and forget about the negative, okay? And that means that you're missing half of your answers. If there are 2 answers, you're only going to have 1 answer. Now, in trig equations, if there were supposed to be 6 answers, you might only have 3 answers. Okay, so super important. The biggest mistake whenever you're using the square root property is to forget the plus minus. Okay, also when you use the square root property, you need to have the squared value isolated first. Okay, so in this case, we're going to divide both sides by 3. We're going to get x squared equals 27. And then I'm going to take the square root of both sides. When I take the square root of a number, I always remember my plus minus. And I want to simplify this if I can. So this simplifies to x, and square root of 27. If you need to do that out with a factor tree, that's fine. But hopefully some of you can recognize that that's going to be plus or minus 3 square roots of 3. Okay, so my answer, I would have 2 answers here. I would have 3 square root of 3 is one of my answers, and negative 3 square root of 3 is my other answer. The square root of sine squared x is going to be sine of x. Excuse me. We're not going to put the plus minus on that. Okay, we're going to put the plus minus on the numbers part. This is the variable part because it contains the x. You also need to remember, this is a property from algebra, that if you have the square root of a quotient, that becomes the square root of the numerator over the square root of the denominator. So an example for that one, this would become the square root of the numerator, 12, divided by the square root of the denominator, 25. And we can simplify from there. The square root of 12 is 2 square roots of 3. The square root of 25 is 5. You guys all should be okay with simplifying your square roots if you're not, come and ask for help. Okay, so like I said, our third problem type is going to be to solve trig equations using the square root property. So how do we know that we're going to need to use the square root property? If we look at our example, we have 4 cosine squared of x minus 3 equals 0. Okay, the trigger for me, the way that I know that I am going to use the square root property, is that I have a trig function squared. I do not have a linear trig function as well. Okay, here the only trig function that I have is squared. That's going to be assigned to me that I'm going to use the square root property. So the same way that I would do this with if this was an x, I need to isolate my variable term. Okay, so the first thing that I'm going to do is I'm going to add 3 to both sides. So I'm going to be left with 4 cosine squared of x equals 3. Then I'm going to divide both sides by 4. So I'm going to have cosine squared of x equals 3/4. I'm going to have to take the square root of both sides. I'm using the square root property. And when I take the square root of a number, I need to remember that plus minus. Okay, that's the step that everyone seems to forget. So I'm going to go up here to the side. The square root of cosine squared of x is going to be cosine of x. And to simplify the square root of 3 over 4, it's still going to have the plus minus. It's going to be the square root of 3, and then over the square root of 4, and I'm going to simplify the square root of 4 as 2. Okay, so my argument on my x is 1. And my interval is from 0 to 2 pi. So all I need to do is think about my unit circle and think about my angles that have a cosine of positive square root of 3 over 2, which will be my pi over 6 and 11 pi over 6. And again, I am not going to do negative pi over 6 because that's outside of my interval. Okay, and then where my cosine is negative square root of 3 over 2 is over here at 5 pi over 6 and at 7 pi over 6. So my answers, I'm going to list them. I always go from smallest to biggest, are going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so this would be my answers here. Pause the video now and try the you try problem. Okay, I apologize. The answers are going to be on the answer key that I posted. Okay, but you can pause the video now, and when you restart, we'll be moving on to the special cases. So trig equations are equations that can have extraneous solutions or no solution. So we need to recognize problems that have no real solution. So I have 2 examples here. And again, we're going to be trying to find the solutions on the interval 0 to 2 pi. So we have cosine squared of x plus 1 equals 0. If we subtract 1 from both sides, we'll get cosine squared of x equals negative 1. Okay, right away you want to see that that's going to have no solution. Okay, and the reason it's going to have no solution is that something squared can never be negative. Okay, if you tried to use the square root property, you would have the square root of cosine squared x equals plus or minus the square root of negative 1. And hopefully you would recognize the square root of negative 1, right, would be I, and that is not a real solution. Okay, and we're not going to deal with imaginary trig solutions in this course. Okay, our second one, the equation's a little more complicated. We're going to add 36 to both sides. We're going to get 4 sine squared of t equals 9. We're going to divide both sides by 4. Sorry, this should be 36. When we divide both sides by 4, we get that the sine squared of t equals 9. When I take the square root of both sides, again, whenever I take the square root, I need to do the plus or minus. The square root of 9, I get sine of t equals plus or minus 3. Okay, but think about it. Our sine of t is always between negative 1 and 1. So can it have the values of 3 and negative 3? Okay, this is outside of the range of sine t, so this is also a no solution. Okay, so right now I would like you to pause the video. I would like you to reflect back and think about what I said. What are you looking for to realize you need to use the square root property? And what are the most common mistakes? Our fourth type of trig equations is going to be when you need to factor the greatest common factor. Okay, so just a quick review. If you have something like 4x squared minus equals x, to solve this, you actually want to subtract x from each side. So you get 4x squared minus x equals 0. And then you want to factor out. You have x times 4x minus 1 equals 0. We factored out the GCF of x. So this is going to be x equals 0, or hopefully you can see that this is x equals 1/4. Okay, the biggest mistake when people do this is that they'll try to divide. And again, this is wrong work. Okay, please do not do this. If we divide both sides by x, I'm going to get 4x equals 1, and I'm going to have the solution x equals 1/4. But do you see how I missed a solution? Okay, I'm missing my solution x equals 0, so I'm missing half of my solutions because I didn't do this correctly. Okay, and so the same thing is going to happen if you're solving trig equations. If you divide by a trig equation to cancel powers, you are going to lose solutions. Okay, so our trigger for solving trig equations by factoring the greatest common factor is when we have the trig equations to two different powers. Okay, see how we have our sign squared here and just a sign here? That's a trigger to me. I'm looking for a pattern that I need to use the GCF. Okay, so we're going to do this the same way that we did with our x. We are going, and again, we're only looking for our solutions on 0 to 2 pi. So I'm going to subtract 2 sine x from both sides. And I'm going to be left with 4 sine squared of x minus 2 sine of x equals 0. And just like above, I'm going to look for my GCF. What's common to both of these factors is a sine of x. So then I have 4 sine of x minus, I guess I could actually have pulled out 2 sine of x. Sorry, I'll do that next time. Minus 2 equals 0. So now I'm going to use the 0 product property. Okay, if these two things multiplied together equals 0, then one of them has to equal 0, or the other one needs to equal 0. Okay, so thinking about my unit circle, my sine x is 0 at 0 and pi. Okay, so my x is going to be 0 or pi. And this is going to simplify. I'm going to add 2 to both sides. I'm going to divide by 4. So I'm looking for when my sine of x is equal to 1/2. Okay, so my sine of x is equal to 1/2 at pi over 6 and 5 pi over 6. Okay, in the interval 0 to 2 pi. So x is pi over 6 and 5 pi over 6. So I'm going to list all of my solutions in order. So I have 0, pi over 6, 5 pi over 6, and pi. Okay, if you have all the answers and they're not in order, you're not going to be marked incorrect. Okay, but you're getting into higher level math. You want to be an organized person. Okay, you want to be more efficient, so take the time to write your answers in order. Okay, pause the video now, do the you try problem, check your answer on the answer key, and start the second video to see the other examples.